I'm going to tell you a little bit about quantum computers and why people care so much about them. There are literally tens of thousands of some of the brightest people in the world today trying to build these machines and understand them. And I'm going to tell you why. But there is a very clear prediction that our most successful theory of nature makes, and that is that there are an enormous number, mind-bogglingly large number, of parallel realities, as real as this one, that have different consistent histories. So imagine a world where all of the laws of physics as we know them are obeyed, but different decisions were made along the way. Different decisions at the level of tiny microscopic particles, different decisions all the way up to what you chose to eat for lunch, and whether you chose to come to this session or not. Quantum mechanics makes a very specific prediction that all of those are as real as the thing that you remember. And this is bizarre, because we don't see those other things. But science has reached the point now where we can build machines that exploit those other worlds. And quantum computers are perhaps the most exciting of all of these that we have within, or almost within our grasp right now. But there's a different thing going on here, which is just as exciting, if not more, and that these machines that supposedly can do this wild stuff, let's forget about how they work, if you could build one, could solve problems that you could never, ever solve. Humans use tools to do things. If you give humans a new kind of tool that can do things that you couldn't otherwise do, imagine the possibilities. So you may think, well, this is all fine and dandy, but aren't these things in the realm of theory and speculation, kind of in the same regime as other futuristic things you may have heard of, which may be allowed by the laws of physics, but aren't here yet? That's not true. There are, in fact, many of these machines deployed now in openly available research centers following the model that was used to introduce supercomputers to the world. There are, in fact, many of these machines deployed now in openly available research centers following the model that was used to introduce supercomputers to the world. But you can give them to a place which will manage them as a shared resource that will offer that service to the world. And there are two of these now. One of them is at the University of Southern California. They're not terrifically powerful yet, but they're doing something completely different than what your computer does. And that thing is like flight. It gives these computers access to these new resources, maybe you could call them parallel universes, in order to do something that you couldn't otherwise do. It gives these computers access to these new resources, maybe you could call them parallel universes, in order to do something that you couldn't otherwise do. And that's not the only one. In fact, the one I'm going to come back to and talk to in the context of the story that I'm wrapping this in was recently installed at NASA. And Google was the primary interested party that pulled this whole thing together. And Google was the primary interested party that pulled this whole thing together. And this one is really exciting to me, because what they're going to do is apply this machine to an area that I think is fundamentally important. It's a crux of our future as humans. And that's, can we build machines like us? This is what they look like. There are two of them. These are from our lab in Burnaby in British Columbia. From the outside, they look like giant black monoliths, big metal boxes. It feels like an altar to an alien god. They really are impressive machines. It feels like an altar to an alien god. They really are impressive machines. In a quantum computer, that device can be in this strange situation where these two parallel universes have a nexus, a point in space where they overlap. And when you increase the number of these devices, Every time you add one of these qubits, you double the number of these parallel universes that you have access to, until such time when you get to a chip like this, which is about 500 of these bits, you have something like 2 to the 500th power of these guys living in that chip. So the way I think about it is that the shadows of these parallel worlds overlap with ours. And if we're smart enough, we can dive into them and grab their resources and pull them back into ours. And if we're smart enough, we can dive into them and grab their resources and pull them back into ours to make an effect in our world. Now, this may sound very odd to you and bizarre, and in fact, I am using language that a normal theoretical physicist probably wouldn't use, but this is, what I'm telling you is absolutely correct and in line with the way that these things actually work. We've been doing this for some time now, and in fact, we have our own version of Moore's Law. The doubling of the number of these qubits on the chip has happened once a year for the past 9 years. So for the last 9 years, every year, the number of these qubit devices has doubled, and it will continue to do so. As a point of reference, in terms of how fast these things, so here's my first prediction. I'm going to predict that by 5 years, NASA will have found an Earth-like planet with Earth-like atmosphere and water on it, and serious people will start discussing how we get there. And by the way, they're going to use one of our machines to help do this. So that's my first prediction. My second prediction is that this business of parallel universes is going to turn out to be very important. This picture that I've got under here is what's called a gravitational lens. When Einstein proposed his general theory of relativity, it came with a bunch of experiments that you could use to test it. And one of them was that if there was a point of light very far away and a galaxy in the middle, that galaxy should bend the light, and you should see a ring. And this was eventually observed. And I think what's going to happen is somebody is going to come up with an experiment to test this reality of these things, and we're going to be able to do so. My third prediction that I'm going to end on is the most important of all. I believe that humanity is on the cusp of the most important technological, societal revolution that's ever occurred. And that's when we got to the point where the machines that we build outpace us in every respect. I don't mean that they're better calculators. I don't mean that they're better at searching. I mean everything. And I think that we're very close. And my prediction is that within 15 years, we will have machines that outpace humans in everything. Thank you very much.